Good afternoon. I'm Cammie Abernathy, Dean of the Herbert Wertheim College of Engineering. Thank you all for joining us today. I think we have a really exciting presentation planned for you. We're thrilled to have Dr. Bonnie Dorr here with us today to discuss human language technology for active defense against social engineering. Dr. Dorr is a professor in the Department of Computer and Information Science and Engineering here at UF. Her research and project management experience include deep language understanding and semantics, large-scale multilingual processing and summarization. She has carried out seminal work in cross-language divergence detection, machine translation, paraphrasing, and automatic evaluation metrics. Together with her colleagues and students, Dr. Dorr has established the new field of CyberNLP, bringing together expertise at the intersection of cyber, social computing, AI, and natural language processing. Her interests focus on cyber event extraction and natural language understanding for thwarting social engineering attacks and detecting stances and other indicators of influence campaigns. Prior to UF, Dr. Dorr was Associate Director and Senior Research Scientist at the Florida Institute for Human and Machine Cognition. She was a professor for 24 years at the University of Maryland, where she co-founded the Computational Linguistics and Information Processing Laboratory and also served as Associate Dean of Maryland's College of Computer, Mathematical, and Natural Sciences. In 2011, Dr. Dorr was a program manager for 3 years at the Defense Advanced Research Projects Agency, also known as DARPA, overseeing research in human language technology. She is a Sloan Fellow, an NSF Presidential Faculty or PCASE Fellow, and a Fellow of AAAI, ACL, and ACM. Highly accomplished in her field, we're delighted to have her with us today. Please welcome Dr. Bonnie Dorr.
Okay, excellent. Thank you for that introduction. So just a couple more details. I started here in January last month, and my research, as Dean Abernathy described, is in human language technology, otherwise known as natural language processing. So I'll refer to that as NLP. And this discipline spans many disciplines here on the campus, both within and beyond computer science, including linguistics and social computing. And my colleagues and I coined the term CyberNLP. My research in that realm continues with colleagues here, for example, in the Florida Institute for Cybersecurity Research. I also focus on core problems and solutions in AI, and most recently, the notion of explainability. So we all know that deep learning has become the centerpiece for many AI solutions, but explaining how or why a deep learning system comes up with an answer is still somewhat of an unsolved problem and is at the heart of my work. So I collaborate with UF colleagues on this topic as well. For example, partnering with colleagues in construction and design to build an intelligent assistant for design, review, and planning of projects. And then in all of the problems that I work on, I adopt a human-centered approach. So this aligns with folks here in the HCC group at UF, and I believe this to be an important aspect of the future of AI, getting machines to adapt to the ever-changing needs of end users instead of the other way around. And then, as Dean Abernathy mentioned, I was in the Ocala branch of the Institute for Human and Machine Cognition, where I worked on human-centered AI problems. And then prior to that, on the faculty in computer science at Maryland, and then at DARPA as well. So I want to start by showing some examples of what makes NLP hard. So I'll present two applications. The first is machine translation, which I may refer to as MT, and the second is in the realm of CyberNLP. So this is a Chinese translation example that I've been tracking for about 10 years. The human translation reveals that the original social media post is about a high-speed train collision in China that involved government cover-up of the cause of the accident and deficiencies in the official rescue efforts. And all of this resulted in public opinion backlash. So the literal translation, which is everyone heart in can guess some more is thus control public opinion, more cause masses heart in arise suspicion. This shows how much information is not explicitly expressed in informal Chinese. This is a blog post. And so that presents a major challenge to automatic machine translation. Now, there are purely statistical MT approaches. In fact, they've done very well on formal documents, articles, and newspaper texts, but at least initially failed to translate informal language in social media. So we get things like we all back in, say, 2012, we all know, can guess a bit, the more people that control the mass media, more suspicious mind. So bit of a problem here. Chinese often doesn't express the subject of the sentence. So in this translation, you can't tell who is controlling public opinion or that it is the people who are suspicious. Also, there's a deeper level of understanding that's needed to infer what a human would understand from this sentence, which is that the government is the unexpressed subject of control. So my colleagues and I have demonstrated that a combination of statistical and linguistic techniques or hybridization yields a result like what we might see nowadays, which is here, like everyone can guess something in their hearts. And the more you control public opinion in this way, the more people are suspicious. So we see the subject of suspicious is the people. Also, the word you is used generically here to refer to the government. So there's still more work to be done here, but clearly this translation is certainly better than early statistical MT. And it's one example of an NLP application that uses hybridization as a solution. And we can leverage that for other types of applications. So this second application spans cybersecurity and NLP, detecting and responding to different types of social engineering attacks. And we've all experienced these. So someone spoofs an authority figure, for example, the dean of the college, to cheat people out of money. I need gift cards for our campus visitors, or access to resources. I need account information to update our grant records. So I'm going to make reference to the acronyms that are shown here. SE is the social engineer, PV is the potential victim. And in our analysis, we noticed that the SE's prompt generally has some form of explicit or implicit demand, or what we call an ask, which isn't necessarily a question. For example, click here is an ask. It's shown in this SE prompt on the left-hand side. And also there's generally a framing associated with the ask. For example, the promise of a 20% discount. And we've demonstrated that the combination of ask and framing, coupled with structural information about the communication channel, provides a springboard for producing an automated response that wastes the attacker's time, perhaps keeping them from attacking other people. Now, the AI response shown here on the right-hand side, this is representative of the use of sociolinguistic principles in our team-developed system. For example, the system responds with stalling tactics. Good to know. How do I go about the process of checking eligibility? Or the website's not opening. Did you provide me the correct link? Is this the one? So we're going to take a deep dive into this example shortly. But first, I want to step back to look at the general challenges in NLP, and it's analogous to artificial intelligence, or AI. These are principles that underlie the solutions or that challenge us to find solutions to different types of problems. So the first is that statistical methods are a bit too shallow for deep language understanding, and that makes it difficult to figure out what's going on in people's heads. How do we figure out someone's intentions and beliefs from their statements through pure number crunching? By contrast, the application of rule-based linguistic principles can often be a bit brittle for large-scale processing and adequate domain coverage. They fail sometimes because it's not always, but sometimes because it's hard to list out all the applicable rules for various language phenomena across language domains, or across multiple domains more generally. And coupled with these challenges is a lack of explainability. So again, black box machine learning techniques, including deep learning, these are now really taking off, but explainability is essential for supporting the ability for developers and end users to really understand what's going on inside the AI system. So I'm going to make the case that we need hybrid systems, symbolic or linguistic approaches combined with statistical and ML techniques to get the best of both worlds. And then I'll focus on applications requiring explainable representations for understanding things like human intentions or beliefs. So I'll start with challenge one. Statistical NLP systems require lots of training. They don't understand the full context of the sentence, so they tend to operate a word at a time or a phrase level. The local context, they use independently trained models. There's no higher order semantic representation to sort out misanalyses or ambiguities, and no deeper semantic information such as the roles of participants in an event. Neural systems and related follow-ons, for example, transformers and vector-based methods, are a huge breakthrough. So these operate at the sentence level, not the smaller local context. The models are trained jointly, and they resolve many misanalyses and ambiguities, but they still lack a deeper level of understanding. And both of these require lots of training. And the more recent approaches actually require more than the older statistical systems. And that could be a huge problem for poorly resourced languages. Also, neither of these approaches takes into account deeper linguistic cross-language generalizations. They tend to memorize predicted outputs for given inputs. So incorporating generalizations both within and across languages can actually reduce training size and can significantly enable the analysis of certain types of constructions that are exceedingly common across languages. And we see this in the earlier machine translation example. Many languages require spelling out motion and manner explicitly. So French would say cross by swimming, and English would say swim across. And that's a well-known divergence. It maps across many different language pairs, generalizes across many different types of manner and motion constructions, not just swimming and crossing. So knowing this can reduce the need for piles of training data, and also retaining this information helps with explainability. I'm going to get back to that shortly. So that's challenge one, shallowness of statistical techniques. But there are pitfalls of purely linguistic methods, most notably their brittleness with respect to undergeneration or overgeneration of incorrect outputs. Good news is that availability of large monolingual and parallel text has bolstered us the employment of statistical and ML methods quite successfully. And if you've run Google Translate, you've experienced this. There are two different synergistic perspectives that my students and I have adopted to leverage statistical techniques to overcome the brittleness of linguistic methods. And the first is statistically filtered symbolic approaches where, for example, in machine translation, we generate multiple linguistically motivated sentences as the translation output. Then we filter statistically. And then similarly, in automatic document summarization, we apply linguistic parsing together with statistical topic detection to produce a one-sentence summary or headline for an article. And these are approaches taken by my students, Dr. Nizar Habash, now at NYU, and Dr. David Zajic, now at Raytheon. We also have another approach, linguistically informed statistical machine learning models, where, for example, in machine translation, we incorporate linguistic principles during statistical alignment of source and target language sentences used for training. These are based on parameterized language universals. For example, there's a linguistic principle that requires direct objects to follow the verb in English, I ate an apple, whereas the object precedes the verb in Japanese, apple ate. These are approaches taken by students, former students, Dr. Najib Fazalayan, he's now at Facebook, and Dr. Nitin Mandani at ETS. And we've studied these for a number of languages: Arabic, Chinese, Korean, Hindi, Spanish, and others. So summarizing those first two challenges, the core lesson here is that hybridization is critical for fuller language analysis. And as we move into the future of NLP and AI more generally, I think we're going to see that more and more at different levels of formality across multiple languages and cultures, and in many cases with poorly resourced languages. And the key point here is that language is noisy. It requires more than just statistics. The community is moving from formal communications to informal and unrestricted media, social media, for example. Also, language is not just about toy examples. We need broad scale statistics and machine learning techniques. We need both of these. So the community is moving from problems with general characteristics to problems applicable to world data. And all this goes hand in glove with the next major challenge, explainability in AI solutions, that I'll talk about next. And I'm again making the case that hybridization is the enabling technology to map to readable forms, such as logical representations, to provide understandable evidence for why an answer came out the way it did, whereas vector-based statistical methods, for example, provide only a bunch of very long feature vectors that are very hard to interpret. Okay, so explainable AI, explainable frameworks have actually begun to emerge, for example, in text classifications, where labels are explained through visualization tools, highlighting input words to indicate salience. But wouldn't it be nice if we could produce a more readable explanation like the one shown here for our earlier translation example? Everyone can guess in their mind, in their hearts, includes correct pronoun usage of their and correct object placement of hearts, with higher probability of correctness, 0.8, versus a lower probability output, everyone heart and can guess some, which would be 0.3. And I posit that hybridization is the key to being able to do this, with the first part of the explanation tied to the underlying linguistic structure, correct pronoun placement or object placement, and the second part being tied to statistical computation, the probability of correctness of the output. So now I see this as scratching the surface. For the question is, what additional knowledge is needed to support explainability, and what would the applications for this be? And that's where my research is headed next, which is to explore linguistic annotations to infer deeper knowledge. In this two-column table, the first column is first order knowledge, referring to annotation with linguistic labels. For example, with mood, linguistic mood, we distinguish guess from can guess, which is permissive, or must guess, which is obligative, and might guess, which is possible. Similarly, dialogue acts, which you can see down here, with these you have labels to distinguish can you do, which is a request, from did why happen, labeled as request information. But there's more beyond annotating with those linguistic labels shown in column 1. Column 2 is second order knowledge, what we can infer beyond those labels. For example, from confidence values, we can take mood labels on the left-hand side, the column 1, and we can infer a probabilistic belief that X may or may not have happened. Similarly, with intentions on the left-hand side, we can get relationships and beliefs. These can be inferred from dialogue acts on the left-hand side. We can infer superior subordinate relationships, or also what the intended activity is, or the associated belief strengths for the reported actions. So now back to our earlier application in the CyberNLP field, where we are incorporating linguistic knowledge into machine learning-based techniques. At the intersection of human language technology and cybersecurity, we have social engineering, active defense. So I'm going to focus on that for the rest of this talk. Just a few basic definitions. What is social engineering? This is the human interaction between an attacker, or what I'll refer to as the social engineer, the SE, and a target, a potential victim. And again, I'm using these acronyms. And here an attempt is made to extract confidential information or gain access to systems. And this is often for financial gain. Another definition, phishing. This is a technique generally achieved through mass dissemination of the same communication to trick potential victims into engaging in a way that perhaps compromises sensitive data. And it turns out that about 3% of phishing emails are opened. And of those, about 5% have success. So what's the deal? Well, spear phishing is something we have to be worried about. It's targeted at the individual level and requires research about the potential victims. Here, the SE may pose as a trusted individual and engage in customized communications with the PV. 70% of these messages are open with a 50% success rate. So maybe we have to be a little bit more worried about spear phishing. And the question is, can linguistically informed representations help? First, an important definition shown here, active defense is a strategy to mitigate or eliminate the risk of harm to a potential victim through interaction. For example, AI chatbots or agents that can assist the human to defend against attacks. In a DARPA-funded project that I co-led 2 years ago, we developed an agent whose task was to waste the attacker's time, possibly long enough to provide opportunities to unveil the identity of the attacker. So now let's delve more deeply into this social engineering application. And here I appeal to what I mentioned earlier as a major theme, addressing explainability in AI solutions. And to do this in the social engineering realm, my PhD students, Brody Mather and Adam Dalton, and I built on lessons learned from the machine translation and language analysis I showed you earlier, where hybrid approaches are both efficient and effective. And we dubbed this new field CyberNLP as shown here. We had our first workshop on this in 2020. So something like check out this great offer sort of falls under this heading. And we built an ask detection system that figures out the ask. For example, in this case is to click the link, and also a framing detection system. So the framing here posed by the social engineer is, this is to the potential victim. It's a gain if the potential victim actually if the social engineer is who they say they are, the potential victim will think this is a gain perhaps. So where do we head from this? We're heading in the arena of trying to figure out the intention behind this. In this case, that it's access to credentials or funds. And this is really the next step for explainable AI. And it's not implemented yet, but we're ahead of the game because we did implement the blue and purple, the first two bullets here, the ask and the framing detection. These are derived from generalized linguistic principles. So now we need to be able to generate explanations like this italicized statement. The intention is to gain access to credentials or funds per the request to click on a link associated with finance or money. And we posit that you can't just do this, you can't produce this type of output from strictly neural net machine learning approaches. All right, so before embarking on the development of an AI agent to help with this problem, with additional colleagues, Larry Bunch and Tomek Strauzelkowski, we undertook an exploration. We looked at the possible sociolinguistic factors to be taken into account. Now, social engineering is prevalent enough that we were able, it was super easy to latch on to a real life email example. And we actually decided to play along for several weeks. So it's sort of amusing. The communication starts with a few lightweight conversational questions by the SE, who is posing as the dean of the college. Are you available? Sorry for disturbing. I want you to help with something. And those are most likely bot generated emails, but shortly we're going to see that the human SE does pick up the ball once we get rolling. This went on for a couple of months on the same email. So the PV, that's our team, we're pretending to be the potential victim, responds non-committally, what's up? Or, okay, what is it? And also we confirm deception with the question, everything okay with the project? The SE then reveals what we call the ask, the demand that they're going to make, which is to go buy a bunch of gift cards, and 5 $100 gift cards to be exact. This is real. I can't make this stuff up. And interestingly, they want actual physical cards. And this specific request is noted by our team. We later leveraged this as a stalling technique. And at this point, we take a break for a while. So and I found it fascinating because the SE does come back and they get impatient. We actually waited a whole week. The SE does get impatient. They don't for one moment suspect that the PV is already onto them, and they don't imagine, what they're thinking is that their authoritative role is compelling the PV to proceed. And they feel perfectly comfortable being aggressive. Are you still there with me? I really need that card to send it to a friend of mine, okay? All right. These are emails. They look like text, but seriously, they are very short emails. Some of them had a 1 week span of time in between them. PV, hey, still want those cards? SE, yes, have you get it? I'm not correcting typos. Those are real. They're actually indicative of an attack. PV, sure, where to send them? SE, send them here for me, attach it with massage here, okay. SE, just scratch it and take a picture of them and attach it to the email, tend it to me here, okay. PV, you said you need physical cards. Again, we refer back to that earlier exchange. Need your mailing address to send. SE, send it for me here now, okay. So we continue stalling, and where is here? Your home address? SE, I mean here, not my house, just take pictures of each of them and send it, okay. So this story is unfolding. We see the SE is getting more impatient, demanding that the PV send an image of the card over email. Some more time goes by, and a few days later, the PV, that's us, finally has a card, or at least we claim to, and we insert an image of a fake gift card off the internet. Actually, it was a little more fake than that. But anyway, the SE gets more aggressive, and of course their grammaticality is plummeting. They demand that the PV send an image of the scratched off code on the back fast. And they use the word fast a lot. And so I'm emphasizing that because I'm just showing you there's no holding back. The SE continues to act like an authoritative superior. Another week passes, they push again, demanding that the card be sent fast. And so we stall, citing security concerns. And finally, we send an image of the back of a card, partially scratched off. And of course, the SE brusquely complains that the code is not scratched off well enough and that the PV only sent one card instead of 5 cards. So you get the idea. We could just go on forever. There's an interesting psychological phenomenon here. The socio-behavioral context is one where the SE is impersonating someone that the PV should regard as a higher up, a dean in this case. So they're relying on that authority effect. And I was astounded myself that the attacker's not prepared for counter deception. We could have actually taken this further, so I'm going to stop there on comments along those lines. But our main point was to show that it's possible to keep an interaction going on for a long time, wasting their time and resources, perhaps keeping them from attacking other people, maybe eventually unveiling their identity. And setting up a bot to do this for us in place of the PV on a grand scale could probably help with this problem in significant ways. So back to our example, we've implemented a chatbot to do this automatically. How did we do it? Our starting point was to notice that each interaction had some form of explicit demand or implicit demand, what we call the ask. It's not necessarily a question. I want 5 gift cards as an ask. We identified 2 types of asks. The first is a give. In this case, the amount I want is 5 $100 gift cards. So this is triggered by the word want. The second type is perform. Triggered by words like contact me, and there's a clickable email address. So figuring out what kind of ask is being employed by the SE is what we call ask detection. And then framing detection, here we determine the risk or the reward that the potential victim might perceive to be associated with the ask if the social engineer were who they say they are. That's a long counterfactual. But let's say they were who they say they were. What would they lose or gain by appeasing or not appeasing the social engineer? So lose is triggered in this case by the SE's use of the word miss. Don't miss this rebate offer of 20%. Gain is triggered by a word like get. You could get up to a 20% discount. All right. So back to our example, again, with the acronyms SE and PV. So the combination of ask and framing, coupled with structural information about the communication channel, enables an AI response. This is a social engineer prompt to school employees. Did you know that you may be able to get a 20% discount, from which our system derives the framing shown here? The details don't matter. You get the idea. And is followed by an ask. Click here to check your eligibility, from which our system can derive an ask. So we leverage those inputs to produce an AI response, and based on the check eligibility ask, the system says, good to know. How do I go about checking or the process of checking eligibility? And next, the response incorporates time wasting to stall for additional information. This website's not opening. And then finally, here's the active defense piece. Sending a new link to covertly verify the attacker's identity. Did you provide me the correct link? Is this the one? And wouldn't it be nice if we had a bot sitting inside our inboxes, flagging such emails, maybe suggesting responses like this? I wouldn't want to let them run loose. The idea would be that the user can look these over and decide what to do with them. All right, some qualitative results. The goal here again is to detect and thwart an attack, but also to waste the attacker's time by playing along. There are 3 attack emails shown here in the first column of this table, and our active defense system computes asks and framings, and we get significant qualitative differences in our response. So columns 2 through 4, we have a baseline all the way out to an improved AI response, depending on the degree of linguistic sophistication that we apply. For example, we applied a simple baseline thesaurus, that's column 2, and we get from that canned responses like, how are you? Or what should I do now? And clearly in these cases, the system doesn't understand much about what the SE said. The third column there, by contrast, so with the same emails, we get a more responsive output when we introduce symbolic linguistic principles to ask and framing detection. So things like, too good to be true, what should I do? Or the website doesn't open, is this the link? And those tend to be time-wasting techniques, and they go beyond canned responses. But the best responses are shown in that final column where we improved the responder to understand more about the structure and semantics of the SE's input, something that is not possible in strict statistical or neural paradigms. And these responses use the same time-wasting tactics, but with purposefully introduced phrases that make reference to the content of the original email. So for that first email, the SE asks the potential victim to make contact. So the improved response is, I will contact ASAP. The third email requests the potential victim check their eligibility by pasting a link. And so the response here is, thanks, need more information before I paste the link. So our system's getting better and better as we move rightward through this table. There's still more work to be done. In fact, there were some more recent improvements last year through machine learned self-attention models, further hybridizing the approach. And this leads us to conclude that the combination of linguistic and statistical or neural techniques can support more focused, automatically generated responses. Just a quick final piece here, that it turns out adaptation of this approach to new domains and new tasks is pretty straightforward. If you think about the lose and the gain that I spoke to you about as two broad ontological categories, and this is the topic of Brody Mather's PhD thesis. So I don't have time to go into all of these, but just a broad brush. We're working on 3 different domains. The first one, social engineering ask detection, is the one we just talked about. The second one, COVID-19 stance detection, is another domain, and then foreign influence foreign influence detection. And each of these domains is at different levels of readiness. And they each have a different motivating question. You could see at the far right side, we've already talked about this first one. So the middle one, do people's COVID-19 attitudes predict how they will behave with respect to COVID-19? Or can, for the last one, can people's attitudes be used to create targeted influence? So we found that if we use this lose-gain ontology, we're able to adapt to the domain of interest in approximately 4 hours. So each domain does follow the ontology. The resulting systems inherit the same foundational mechanism for addressing explainabilities in the ways I've described. Just one prototypical example, the middle one there is stance detection. Here we are computing attitudes, for example, in the COVID domain toward mask wearing or social distancing. And this is an online conversation among Jan, John, Tim, and Jean. And what makes it different from ask detection, these vector-like representations look a lot like the ask representations I showed you before, but what we had to add was this belief component. What's their underlying belief that causes people to act or have particular attitudes? For example, a rejection that masks are protective, which would be a -3 belief that they protect, or that they cause illness, maybe CO2 poisoning, which would be a positive belief toward causing illness. And what's interesting here is that we're able to borrow the same notions of lose and gain in our framings, where in the conversation at the top here, restrictiveness and illness are viewed as a lose, and freedom, not wearing a mask, is viewed as a gain. And again, we end up with these readable representations where we could express an intention and an explanation as we move toward explainable AI. Something like this conversation up here is against mask wearing, given the beliefs that masks are non-protective, they cause CO2 poisoning, they're restrictive, and you can gain freedom if you don't wear a mask. Again, another step toward explainable AI. And in contrast to strict neural vector-based approaches, we get this foundational framework for being able to do this. And we see this if we compare it to the state-of-the-art sentiment detection by neural systems. So why not just use state-of-the-art sentiment detection instead of this stance detection of attitudes? And we did this comparison and discovered that the underlying representation that includes belief does get higher accuracy because of things like double negation. We can say, and people do say on the blogs, well, I don't like not wearing masks. It's sort of a hedging approach to a positive attitude toward masks. Very tricky there. Allen AI Institute has a sort of state-of-the-art sentiment detector that considers this a negative attitude, whereas we consider it a positive attitude. That just focus on the last element here, that the attitude, which ranges from -3 to 3, is positive in this case with respect to the protectiveness of masks. So with sentiment detection, we still don't have really a targeted state-of-the-art sentiment detection out there. But with stance detection, we get a targeted attitude toward a particular thing. And the other thing is that there can be two perspectives, right? So if the governor requires mask wearing, so somebody says the governor required mask wearing, you don't know if there's a positive or negative attitude toward mask wearing. State of the art doesn't really tell you what the sentiment is toward, it's just negative here. Whereas if you break it down into underlying beliefs that masks are restrictive or masks are protective, you can get different attitudes. So maybe this statement is a negative attitude toward mask wearing, or it could be a positive attitude toward mask wearing. So breaking it down really gets you, with linguistically motivated belief representations, gets you the next step toward explaining the rationale behind the output values for belief, sentiment, and attitude. So I'm going to close. Where are we headed next? I'm looking at stance detection in the face of cultural distinctions. For example, cross-cultural negotiations. People have different moral values and beliefs, and so often talk at cross purposes. So how do we overcome that project? I'm actually working on the civil sanctuary project in DARPA, where this is very important. And I mentioned that hybridization for explainability is research underway. It's not yet implemented, but we do plan to map from representational formalisms to human readable descriptions of NLP output. And then another area is incorporation of multiple modalities. So bringing together AI, vision, NLP to figure out what people are saying through multiple means simultaneously. It's important to fuse all of those inputs. That helps for explainable AI. Humans can figure out what went wrong in the interaction quite easily with gesture and speech cues. That gives the whole picture, but computers really need to catch up. And then finally, doing all of the above in multiple languages. It's a small bullet, but it's a big task. But it is where we are headed next. So I want to thank you for your time, and also thank you very much for inviting me here today.
Thanks for that fascinating presentation. It was great. We are now going to accept questions from the audience. Please post them in the Q&A or the chat. I did just want to start with one observation, though. Some of these SEs must not be very smart. If they think impersonating a dean is going to get people to respond, no way. So,
oh, you underestimate the power of the dean.
There is none, let me tell you. So we have a couple of questions here. Let's start with, for the problem of shallowness of current neural models, do you think we need to look to the literature on semantic parsing into logical forms? And if so, what's currently lacking to make that structured prediction happen?
I think we're poised to do it now. And yes, semantic parsing is absolutely a part of the picture. That, in fact, a lot of what we've moved into to be able to bring out the sort of sociolinguistic aspects, but also linguistic aspects, is semantic role labeling, where you actually figure out what the role of the people would be in a particular activity. And that requires semantic analysis beyond just looking at the surface structure or word order or frequency of words in the sentence. So absolutely, semantic parsing is central to what we do.
For the problem of spear phishing, how do you consider ethnic nationality differences that may exist in the communication? For example, not treating an English learner as an attacker based on errors.
Yes, there are definitely ethics issues to address here. And we never take a single indicator to mean, we never just say this absolutely means X is happening. Misspellings means attack. We never draw that inference directly. There are a lot of indicators taken together. For example, if the ask is focused on a particular sensitive area, and there are typos, and there's some sort of framing leading up to the, it's a confluence of all of these things taken together that allows us to have, we never have certainty, but higher confidence that something might be at least a red flag, something to be examined, but not taking action even under those circumstances. It would need to be reviewed, and all of these things taken together. That interaction went on for a very long time, and probably typos weren't the most salient part of it, but it was a piece of it, a tiny piece of it.
So the next question is sort of about countering the counter. Do you see this going the way of adversarial models where attackers get hold of such a model and make it harder and harder to detect fraud?
Yes, and most programs coming out of DARPA, for example, but also IARPA and some other, usually defense contracts nowadays are headed in the adversarial. There's a game playing mechanism associated with it. It's all AI, all the adversarial techniques are going to be needed, and they have usually an A team and a B team, because every solution you can come up with can be countered, and then that can be the counter of the counter, as you stated in the question. So yes, adversarial work is absolutely needed in most programs nowadays in this realm.
Lots of kudos for your presentation, lots of thank yous. A question about data acquisition. What does your data acquisition process look like?
So it depends on the sponsor. And so for one of the programs 2 years ago that I was in, and it actually was focused on the social engineering problem, they actually had humans creating the data on the fly. And so they had to sort of correspond with our system. It was very nerve-wracking. We were hoping that it didn't sound too canned, even though we put every sophisticated thing we could think of in there. So data acquisition wasn't even a part of that equation. And you can go all the way, but that's our approach. I mean, other people did train on data, and it was usually things like Twitter data or things like that, where there was availability through APIs, where you could program through the Twitter API, and you could, particularly as academics, we have access to that. It's open, it's available with various, you can't go selling it or doing weird things with it, but that data is freely available. Because social media has taken off, we actually have access to a lot of data. There's also something called Kaggle. There's a Kaggle competition every year on a whole bunch of different areas, and they have a big Twitter corpus. So we've used that for the COVID domain and other domains as well. And so there's interaction. All we need is some form of interaction to sort of at least look at it and study it and figure out what's going on. Some people need it for lots of training. We try not to rely too heavily on having lots of training data, because then we're stuck if we're in a domain where we don't have the data. So, but there are people who do use it for training. We tend to use small pieces of it for just studying and exploring and investigating what's needed.
Have you thought about applying your techniques to voice calls? There has been some very limited work in this space. For example, Lenny, with only 5 to 10 phrases, but lots of room for interesting work.
Yes, earlier work that I did was speech oriented. The last, I don't know, 3 to 5 years has all been text oriented. I think it swings back and forth, but as we move into informal genre, social media, it's completely the same idea. People speak the way that they write in very informal text. So the idea would be ASR is very good at automatic speech recognition. It's very good nowadays. So to transcribe that even multilingually into whatever informal text looking output should feed into the types of tools that I've presented. The thing that would be missing if you do it that way is maybe there's some tone or pauses or things that are important in the input that you would want to make sure you don't lose that. And I haven't heard of people fully integrating things like that yet, but I think that is one of the waves of the future.
How does the semantic parsing take into consideration for the tone of voice? For example, English language itself has many problems that come up from its structure, where what we write is not what it sounds like.
Yeah, and so my last comment was a segue to that. So tone is an area of NLP research, not my area, but it is a very solid area where people are looking at tone, pauses, Also, very early on, say 15 years ago, I did some work on disfluency detection. Why and when do people say or things like that? And there's other things beyond that. People tend to repeat the word I think. So is there a way to understand what is that a hesitation, or is it just people just talk that way? And tone can really mean a lot. So you can emphasize the volume, the pitch, all of those things can come out, and people have indeed worked on that. The semantic parsing I talked about is kind of orthogonal, but should work in conjunction with that. It's tackling a different problem, but tone, features associated with tone could perhaps be brought into the semantic parsing world. I wouldn't rule that out.
How do you evaluate potential rapport between an attacker and a victim, i.e. context? So for example, an attacker trying to mimic a conversation between you and your parents versus another conversation between you and your colleague.
So it's probably less often used for you and your parents. And the reason is that org charts are so readily available on websites. And you can imagine the first place to turn would be an org chart to figure out, I have tended to get, depending on what my position is, can either be the chair of the department or the dean of the college, depending on where I sat in an organization, or the CEO of the organization. And I know other people in my organization who got those same, or I didn't realize they weren't ignoring them. And I was working on this research and I was thinking, wait, no, I'm working on that research. You should know not to click those, but they did buy the gift cards. But anyway, so it's surprising the returns you get out of this, by the way. I mean, I figure if they're just researching and they're getting a high, bang for the buck, even though it's a smaller set than the mass dissemination, they're doing that just by looking at org charts and other information out there. So if there are, social elements in, say, personal life that are posted, perhaps that could also be leveraged. I just think it has happened a little bit less often, because you can make it a formal, a sort of official looking request in sort of the business world, whereas it's sort of harder to frame it when you don't really know the relationship between a parent and their child. But yeah, I think org charts is the answer to the question. That's what makes it more frequent in the business world.
So Bonnie, I'm going to ask you to look into your crystal ball for a moment. Fast forward 5-10 years. Tell me what's happened in this field and what that means for our participants today. What does that mean for people in their daily lives?
So one thing is that ethics question that came up. We constantly have to be looking at that, and ensuring that we're using best ethical practices, and at the same time, as in that question that was asked, it was a really important one, ensuring that we understand there are cross-cultural distinctions. So cultural analysis is still something that I could see 5 to 10 years out, people are still looking at that problem. And being, diplomacy, being able to work across cultural barriers, I think would be and it's human-centered as well. It's all about the human, not the machine. The human should drive the machine, not the machine driving the human. So I think the cultural dimension is going to be very, very important and will continue for the next 5 to 10 years. I think the adversarial framework that came up during this conversation is absolutely going to, I'm not going to say we'll ever solve any of these problems, but we're going to be a lot closer in understanding how to combat various issues and challenges that arise, but understanding that combating that can also be countered. So I think adversarial AI is really important. And then explainable AI, which is my big, I just want to understand why the machine came out with the answer it did. And I used to be able to do that really easily. And I want to go back to those days. And so if there's a way to embed, not word embedding, which is certainly vector-based neural approaches, but actually embed in the system some level of representation that can allow us to understand the answer that came out. I think we will eventually get there in the next 5 to 10 years, where we can produce the types of readable output that I presented in the talk. Fingers crossed, we'll keep working on it, but that's what I see in the crystal ball, maybe.
Well, the next question is related to how these models will be used. It says, how do you see these models being used in practice? Are you thinking, say, decentralized browser extensions or a centralized platform like Gmail incorporating it in their platform?
I would advocate for individual level app. You get control over it. You tailor it the way you want. Again, it's all about the human, and we humans are not all alike. And so it's not one size fits all. And also, it shouldn't be imposed. It's a decision that a human can make. Do I want this thing sitting in my inbox, reading emails? If it's individual and on your system, and you can guarantee that it's not data being collected and disseminated to the outside world, which a centralized solution would bring that in, it's not necessarily a good thing, right? So just your own agent, just like you have a lot of other apps on your laptops and your phones and so on, that some of those are collecting data, right? So you'd want it to be, there are privacy issues there, but I see the potential for using apps like that individually on your machine in customizable ways, with community input on what the customization should be. I'm not an HCI person. I don't work in computer interaction, but those are central issues in that area that would need to be addressed. And I think there are probably other uses, but that's probably the application area that I'm most interested in, having something on. I would love to have it on my machine. Of course, like I recognize these attacks and have fun with them. So I don't know, but I wouldn't mind having, testing a few things out. If I had an app like that on my machine, I'd like to see what happens. So yeah, I don't think it should be centralized. That's just my take on it.
This feeds into another sort of issue that people have talked about. It's not exactly your area of research, but it does touch on what you said about keeping your own data and not having it harvested by larger organizations. Could this be another part of this movement to have people control, but also be able to monetize their own data? Sort of a
yeah. I think it's entirely related to that. I think I think centralized can cause problems, and I think if you can individually control your own data, make your own choices about what happens with that, and transparency with respect to, because you're the owner, so it's by definition transparent to you. Transparency across centralized solutions would be nice too. So it's related to that issue, and it's definitely a hot issue. And DARPA is very interested in this. So what are those algorithms going on in Facebook for real? We don't know, right? So yeah, I think that if you want to know what's going on, not only should it be the data that you own, but the algorithms underlying the apps, understanding how those work in ways, described in a way that's not like, well, 3 vectors get multiplied. It's something that you can really understand and grasp. I think that would be very important.
We have a question here about when dealing with the real world phishing emails and texts, do you use any sandboxed environment?
In the DARPA evaluations, that's what they had. They did have sandboxed environments, and they had different ways of evaluating. So they gave us the opportunity to have how did this work? There was human, so they allowed us to have a human respond. They would send us these emails on a special site, and we had to go and respond as a human. Then we had a hybridized human bot. That's a complicated, I'd have to go through details of what that means, but it was a combination, like human input to a bot, and they allowed us the freedom to define what that was. Each team had their own. And then there was the bot alone. And so at the other end were these human evaluators. We didn't know who they were, and we got feedback for each of those approaches. And there were definite component level sandboxes as well for each of those, right? So people who are sort of a part of understanding the dialogue. There's a structure to dialogue, so discourse structure it's called, and then there's sort of semantic understanding, and then there's syntactic, and there's response. Response generation is a whole field unto itself, many dissertations worth. So those also had sandboxes and could work as teams together to try to get the best output.
So time for one last question. What about fake news detection? I feel like that would require the models to do more than just linguistic analysis and need to be grounded in world knowledge. Fake news detection is a hot topic right now. What do you see in that field? I've
been involved in a lot of it. But it's funny because I'm becoming more, I tend to be more on the analysis side than the synthesis side, but I'm moving in the synthesis direction because responding to fake news has to be done very delicately. You polarize even further if you just say, look, read this article. And also it's not going to get read. So we've built this, a couple of years ago, we talked about building this counterpoint system. And it's sort of controversial as to whether posting counterpoints works. I do think there's data, and in fact, there was a recent article, I think it was 2 days ago, on showing that forwarding things does get a little bit curbed if it's flag. Like if there's a post that gets a flag, then maybe still there's a lot of people who believe it, but it won't proliferate quite as much. People curb their forwarding once they see that. So to me, the most important thing with fake news is less detection. I mean, it's a problem unto itself, and I have some thoughts on that. That requires a lot of information retrieval, and then how would you construct a counterpoint anyway? Well, there's all of that, but then how you present that counterpoint and is going to be really important. And this comes down to the cultural distinctions we just talked about. It comes down to beliefs and moral values, and being able to understand those when you respond and really truly understand, like take both perspectives, or there's 5 perspectives, maybe multiple perspectives, understanding those before making a statement. And so I've been thinking hard about this because I guess sometime this semester I have to give a brief out to DARPA on kind of this topic. I've run 2 workshops on it. They were year-long, so a lot of work. And yeah, so I think that's going to be important. The whole cultural, the understanding people's perspective, what their core beliefs are that led them into a particular area. If you can't figure that out, just kind of lecturing at them is not going to work.
Bonnie, thank you so much. This has been terrific. And again, we're so happy to have you at the University of Florida. I hope you'll get a chance to come back and visit us again at some point in the future. But thank you again for being with us today. So at this time, we'll conclude our presentation. I'm going to thank all of the attendees for being with us today. We'll be in touch with information about our next webinar soon. Thank you so much for joining, and go Gators.
Thank you so much.